Hi, this is Mikhail Golovnia, Senior Scientist at Salford Systems. What I'm going to discuss in the next few video segments is the importance of variable selection and also all of the facilities available in SPM to help you deal with that process. The variable selection is very important for several reasons. Well, usually when you start working on any real-life consulting project or data modeling task, you have a data set with potentially a large number of potential predictors, and usually you will eliminate some of the obvious illegal predictors of the bat, things like ID variables or alternative versions of the target variable, things like that. But at some point you will always have to face that collection of predictors that you consider as a potential predictors, and you will want to manage it somehow or try to reduce it in size. In other situations, you will also have to deal with things like brainstorming session and creating potential additional new predictors, and it's often some kind of teamwork, group work, when you explore different possibilities and different ways to structure whatever set of predictors that you have. But to make the long story short, sooner or later at some point there will be the need to manage and reduce the list of candidate predictors down to the minimum set that is easy to manage, and it also has a nice predictive capabilities. And now the importance of predictor reduction also comes from an alternative side of the principle of statistical parsimony. So you don't really want to have too many variables being actively used as part of your final models. And having started with, say, a set of 500 predictors or 1,500 predictors, the ultimate idea is always to try to reduce that list down to some manageable level. What I'm going to do here is I will show some of the important automation facilities available within SPM that can help you deal with that specific situation. Now, I will use a toy example, the spam-based data set. The data set is pretty straightforward, and we will just run it as a quick illustration of some of the most fundamental pieces of machinery available to you. So let me get started and see what can be done. I have SPM running here. So first I'm going to open the spam-based data set. It's a CSV data set over here. 4,601 spam emails, all emails spam and no spam, all described in terms of bag of words approach. I already talked about this data set a number of times. So I'm going straight into modeling side, and in my case, just for the sake of illustration, I will use cart engine because it's the fastest way to get an individual model. So we will work in classification mode, and I will sort all of my predictors in file order, and the target variable is a binary variable that communicates whether each individual email is either spam or no spam. So target is my target variable, everything else is a predictor, and in this case testing will be set to 20% randomly allocated test sample, and I'm also going to set some reasonable limits. Well, I'll limit parent nodes to have at least 10 emails and terminal nodes to have at least 10 emails. Now notice I'm starting with a set of 57 predictors, and I'm going to try to figure out whether I can reduce that set of 57 predictors down to a much smaller set while keeping my overall model performance, model accuracy. First, let me build a simple model just to see what the off-the-bat modeling brings me to. Okay, so the model is complete, and now as you can see I'm getting the relative cost of 0.185. I have a tree like that, and when you go on the summary reports, the variable importance list communicates what are the predictors that were selected as participating in model building, either explicitly or implicitly. And in this case, 49 out of 57 were selected, which pretty much almost all of the variables initially available to me. Now, before I proceed any further and look at the variables that are shown as least important, the top most important question that I need to investigate is whether the variables that are shown as most important really are important. And the reason for that being is that in data mining, the model is usually built based on the training data, and it's then later evaluated based on the test data. And especially in those cases when there is non-random partitioning into training and test data, most notably based on the timeline or some other considerations, what sometimes happens is that if the variable looks very important based on the training data, it does not necessarily mean that it generalizes well with respect to the test data. Now, you can do some hand experiments. So you could say, okay, what if I remove $sign and rerun my model? Is my performance going to improve or degrade? What if I remove exclamation mark? What will happen? So you can do a lot of experimenting by hand, but you can also invoke a special machinery of SVM that allows you to automate the thing, and we call it battery shaving. So what I'm going to do next is I'm going back to Model Setup, go on the Battery tab, and find battery shaving as the facility that I'm going to investigate here. And this will be the center topic for all of these video segments. Now, battery shaving is selected. Now I want to set some of its options. And in this case, I am trying to understand whether the most important predictors, as reported by my initial model, really are important. So in this case, I will be doing shaving from the top. And what the shaving from the top will do, it will identify the most important variable based on my first run, remove it from the variable list, rebuild my model, look at the next most important variable, remove it from the list one at a time, predictors to shave one at a time, and then we'll keep on doing it until it eliminated all of the variables. Now, I don't really want to do that process all the way, so in this case, I will do shaving from the top, but I will only complete 5 steps. And let's see what's going to happen if I do that. So I'm click OK, and then I click Start. So now notice it runs 6 individual trees. The very first tree, nothing is shaved, and then it progressively eliminates the most important variable. So the end result is shown on this little report here. And as you can see, in terms of relative cost, as I remove my $sign, the accuracy of my model actually improved. And as I remove the frequency of the exclamation mark, the accuracy of my model improved even more, because the relative cost, the smaller the relative cost, the better the performance. So in this case, and also in the table form, as you can see, the very first model has all 57 predictors and no variables were shaved. The second model has character frequency of $sign removed, so you have a 56 variables now, and my relative cost actually improved, and the same goes with the frequency of exclamation mark. It improved even more. And then as I start eliminating other variables, now my accuracy starts degrading, and in this case it almost feels like basically these 2 variables, even though they're shown as the most important variables, once you remove them from the list, the overall model performance goes up, and therefore we can focus on this model that has 55 predictors as the first candidate model that will be a reduction. Okay, so now we have a model that has a smaller number of predictors and the relative cost of 0.155. So what we have learned at this point is that whenever you work with a new set of predictors, before focusing on predictors that appear to be the least important ones, you actually have to analyze whether the predictors that are shown as the most important ones are indeed important. And what you will discover time and again is if you eliminate some of the most important predictors, you may actually improve the performance of the underlying model, because something that looks as important on the learned sample may not necessarily generalize well to the test sample. So shaving from the top is a very important first step. It can be done either by hand or by relying on this SPM automation. In the next segment, we're going to pick up where we ended here, and I will show, and at that point we will focus on the variables shaving from the bottom.